Hello everyone. So today I am going to be informing you of the process of treating skin cancer as a Mohs histotech. So every day, thousands of people in the United States are diagnosed with skin cancer. For many, the word skin cancer can be very frightening. What most people don't realize is that in most cases, a lot of the important work is done in treating behind the scenes, behind the microscope. So today I will be demonstrating how a Mohs technician plays a vital role in curing skin cancer. The first step would be receiving and preparing the tissue. The next step is freezing and cutting using a cryostat, which I'll explain later. And then lastly, staining and examining the slides for the surgeon. As a Mohs histology technician, I'm one of the people that prepares and processes the tissue samples to help determine if the skin cancer has been completely removed. I work side by side with the dermatologist surgeon, and I see firsthand the precise precision that is needed in the lab to get the results perfect. You can't mess up in a lab, so you have to make sure you get every step done in the correct manner, the correct way, so that the end result is perfect. So, like I said before, we'll review receiving and preparing the tissue, freezing and cutting using a cryostat, and staining and examining the slides for a surgeon. So, today I'll explain the first step, which is receiving the specimen. Once the surgeon cuts the tissue off the patient, we then bring it into the lab. In the lab, we have to verify that all the information is correct, that the map, the documentation that they have for the patient matches what the specimen is. There is a map that they draw. The specimen has to look exactly how the drawing is. It has to match. Usually what the doctor does is they notch at 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock, kind of like a regular clock. And we proceed to ink the tissue. Therefore, we grab the colors. Usually 12 o'clock is blue, and whatever color the surgeon wants to use. Once you ink the tissue that way, then if it is positive at the end, he'll know exactly where to go back if he needs to, if there's more tumor in that section. So what I proceed to do is go ahead and ink it, cut the tissue to make sure that all the lateral edges, all the epidermis, and the fat is leveled all the way down onto a slide. Then I go ahead and put the slide in the microscope, not the microscope, sorry, the cryostat, and I let it freeze. We go ahead and put a medium called Neg 50. This medium is used to freeze the tissue and also combine it with something called a chuck. So once we combine those two things together and they freeze, we go ahead and move that chuck that has the tissue on it, frozen at negative 26 degrees Celsius, into the area where it needs to be cut. Once we start cutting sections, they are very thin. They're about 1/10 of the thickness of a human hair, so it's very thin. Those sections are then cut. We place them on slides, and we go ahead and begin staining them. We use something called H&E staining, which it stains the nucleus, a different color from the rest of the tissue. So when the surgeon is reading under the microscope, he knows the difference between all the cells, and he can see where the tumor is, if there is any. Once the surgeon begins reading, if the patient is still positive, then he'll go in and take another section of the tissue, and we repeat the same process with the different inking color pattern, or the same one, whatever he chooses, and we restart the process. That is basically it for that. In conclusion, we went through the receiving of the specimen, processing of the specimen, and staining of the specimen. And that is all for today. Thank you.